In today's video, we are going to compare two solar panels that have the same rated power, but very different designs. One is a 130-watt flexible solar panel, and the other is a 130-watt rigid solar panel. A while ago, someone told me that flexible panels are almost as efficient as rigid panels, and that for things like RVs or camper vans, they are much easier to install. According to him, there was basically no reason to choose a rigid panel anymore. At that time, I had not personally tested it, so I did not make any strong claims. But recently, I finally managed to run a real comparison using two panels with the exact same rated power. So in this video, I will show you the results of two simple tests and explain what really happens in real-world conditions. We will look at the performance difference, the effect of heat, flat installation versus tilted installation, and the real advantages and disadvantages of each type. Now, before we get into the numbers, it is important to understand something. Solar panels rarely produce their full rated power in normal conditions. The rated power is measured in laboratory conditions called standard test conditions, where the light intensity, temperature, and angle are perfectly controlled. In the real world, temperature, panel angle, and airflow can all reduce performance. That is why practical testing is useful. So let's start with the first test. Flat installation. For the first test, both panels were installed flat. On the left, we had the 130-watt flexible panel. On the right, we had the 130-watt rigid panel. Both panels were connected to the same MPPT charge controller, a Victron model with Bluetooth. This allowed real-time monitoring of the energy production, so the comparison stayed fair. The flexible panel was taped onto a wooden board, so it stayed completely flat. The rigid panel was mounted on wooden spacers about 2 centimeters high to simulate a normal installation with some airflow underneath. Both panels were then tested for 1 hour in sunny conditions. Let's start with the rigid panel. The rigid 130-watt panel produced an average of 79 watt-hours during the test. Considering the rated power is 130 watt, this represents a real efficiency of a little more than 60%. This already shows an important point. When a solar panel is installed completely flat, you lose a significant amount of energy compared to optimal conditions. During the test, the temperature of the rigid panel reached about 41 degrees Celsius. Now let's look at the flexible panel. The flexible 130-watt panel produced an average of 63 watt-hours. That corresponds to roughly 48% efficiency compared to its rated power. But the most interesting difference was temperature. The flexible panel reached around 53 degrees Celsius, which is much hotter than the rigid panel. And this is where one of the biggest problems with flexible panels starts to appear. Because flexible panels are often glued directly to a surface, there is almost no ventilation underneath. Heat gets trapped, and higher temperature reduces the electrical efficiency of solar cells. So even though both panels have the same rated power, the flexible one lost significantly more energy due to overheating. From this first test alone, we can already see almost a 20% performance gap between the two panels. But this was only a flat installation. So the next question was simple. What happens if we tilt the panels toward the sun and improve ventilation? That is exactly what we tested next. Tilted installation. For the second test, we wanted to create conditions that are closer to what you would normally see in a well-installed solar system. So this time, both panels were tilted toward the sun instead of being installed completely flat. This also allowed better airflow underneath, which helps reduce heat buildup. Everything else remained the same. Both panels were still connected to the same MPPT charge controller, and the production was monitored under the same sunny conditions. Let's start again with the rigid panel. With the improved angle and ventilation, the 130-watt rigid panel produced an average of 90.4 watt-hours during the test. That corresponds to about 69.5% efficiency compared to its rated power. This is a noticeable improvement compared to the flat test, where it was producing around 61% efficiency. The temperature measured during this test was about 44 degrees Celsius, slightly higher than before, but still within a normal operating range. Now let's look at the flexible panel under the same tilted conditions. The 130-watt flexible panel produced an average of 76.2 watt-hours. That represents an efficiency of about 58.6%. The temperature recorded this time was 46 degrees Celsius, which is much closer to the temperature of the rigid panel than in the first test. This is interesting because it shows how important ventilation and panel angle are for flexible panels. When the flexible panel was flat and glued to a surface, the temperature reached 53 degrees Celsius, which significantly reduced its performance. But once airflow improved, the temperature difference between the two panels became much smaller. However, even with better cooling and the correct tilt, the flexible panel still produced less energy than the rigid one. In this second test, the performance gap between the two panels dropped to about 15%, but the rigid panel still remained ahead. Looking at both tests together gives us a clearer picture. When the panels were installed flat, the rigid panel reached about 61% efficiency, while the flexible panel reached around 48%. When the panels were tilted toward the sun, the rigid panel improved to nearly 70% efficiency, and the flexible panel increased to around 58.6%. So, tilting the panel clearly improves the performance of both types. But it helps the flexible panel a bit more, because it reduces the overheating problem that happens when it is glued directly onto a surface. Even so, the rigid panel still stays ahead in terms of overall output. Another point worth mentioning is that these panels are 12-volt class solar panels, which are commonly used in small off-grid systems like camper vans, boats, and portable setups. Higher voltage residential panels, such as 24-volt or grid-tie panels, often operate more efficiently and experience lower losses in certain situations. But for small mobile systems, 12-volt panels are still very common because they match well with typical battery systems. So the key takeaway from these tests is simple. Even under better conditions with good ventilation and proper tilt, the flexible panel does not quite reach the performance of the rigid panel. But performance is only one part of the story. To understand which panel actually makes more sense in real life, we also need to look at their advantages and disadvantages. That is exactly what we will cover next. Let's start with flexible solar panels. Flexible panels have a few clear advantages. They are very light and very thin, which makes them easy to transport and install. This is especially useful on camper vans, boats, or small RV roofs where weight is important. Another big advantage is installation. Flexible panels can often be glued directly onto the surface, so there is no need to drill holes in the roof. They are also more discreet visually, because they follow the shape of the roof and do not stick out like rigid panels. For temporary setups, they can also be practical, since they are easier to remove and store. However, flexible panels also have some important disadvantages. One of the biggest concerns is lifespan. Many flexible panels last only 2 to 5 years, and their performance can degrade faster compared to rigid panels. Another issue is overheating. When these panels are glued directly to a surface, airflow underneath is very limited. This increases temperature, which reduces efficiency and speeds up material aging. Flexible panels also use plastic protective layers instead of tempered glass, which can yellow over time, develop small cracks, and lose transparency, reducing performance. They are also less resistant to scratches, impacts, and hail, and repeated bending can damage the solar cells. Because of these factors, the price versus lifespan and performance is often not as good as many people expect. Now let's talk about rigid solar panels. Rigid panels are built with tempered glass and an aluminum frame, which makes them much more durable. Many of them are designed to last 25 to 30 years. They also maintain more stable performance over time and degrade more slowly. Another advantage is better cooling. Since rigid panels are usually mounted slightly above the surface, air can circulate underneath them. This helps remove heat and improves efficiency. Rigid panels are also more resistant to weather, including wind, ultraviolet light, hail, and temperature changes. There is also a much wider range of options available, including higher power models and newer technologies like bifacial panels. And in recent years, rigid panels have become very affordable, which makes them a strong, long-term investment. Of course, they do have some disadvantages. Rigid panels are heavier and thicker, and they normally require a mounting system, which often means drilling or installing brackets. They are also more visible on a vehicle roof compared to flexible panels. So, what can we conclude from these tests? The idea that flexible panels are just as efficient as rigid panels is not really supported here. In our tests, the 130-watt rigid panel reached close to 70% efficiency, while the flexible panel stayed below 60%, even with good tilt and ventilation. That does not mean flexible panels are useless. They can still be a good option when weight, space, or simple installation is the priority. But if you want better performance, durability, and long-term value, rigid panels are usually the better choice. One last tip. Panel angle and airflow matter a lot. Even a good panel can lose power if it is flat and overheating. So try to give your panels some ventilation and aim them toward the sun whenever possible. Thanks for watching, and don't forget to subscribe to Battery Hacker.